Okay, in this presentation we have four planar graphs. What we're going to do here is we have to calculate the number of vertices, which we're going to call V, the number of edges, the number of regions in each map, and then we're going to verify Euler's formula. So in this case, what we have here, this is our first one here. So we have five vertices, 1, 2, 3, 4, 5. There we go, straightforward enough. So V in this case is equal to 5. V equal to 5. I'll just bring it down there just to make it a little bit easier. So in the next case, what we have to do here, see if that's in shot better. Good. The next thing we have to do is calculate the number of edges. Okay. So let's just go around the outside first. 1, 2, 3, 4, 5, 6, 7, and 8. So the number of edges is 8. Okay, it's handy for me to sort of go through them like that. Okay, so E in this case is equal to 8. Okay, the next thing we have to do is we have to calculate the number of regions. So I'm just going to sort of, first off, we have the out region outside. Okay, outside the perimeter. Then we have this region here, this region here, this region here, and this region here. So in this case, what we have here is 1, 2, 3, 4, 5 regions. Okay, so in this case, R is equal to 5. So let's just see, do we get V plus R minus E is equal to 2? Well, V we found to be 5, R we found to be 5, and E we found to be 8. So 5 plus 5 minus 8 is equal to 2. So that verifies Euler's formula for this example. So we'll move on to the next one here now. Okay, so this is our second example, example B. And first off, what we'll do is count the number of vertices. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That was straightforward enough. So V is equal to 12. Okay. Now, the next one is edges. Now, this is going to be a little bit of work. So, what I'll do here is actually just count out the external edges, the external boundary. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 10 in the external boundary. Let's just make a note of that. And then the internal edges 1, 2, 3, 4, 5, 6, 7. Okay, so the total number of edges is 17. The reason I broke it up there is external ones and internal ones. I just felt like doing that. It just made it easy for me to sort of identify which is which and not double count any. It also helped that I was coloring them in, if you get me. Okay, the number of regions. Now this one's straightforward enough. So we have the external region here, 2, 3, 4, 5, 6, and 7. So let's piece that all together. Scroll that up. So we have 12, V equals 12, and R is equal to 7, and that is equal to, what was that, 17. Okay. Oops, I went a bit too far there. So V plus R minus E is equal to 12 plus 7 minus 17. So that is equal to 19 minus 17, which is equal to 2, which is great. Okay, so we'll do the next one now. Just going to pause it a second. So this is our third example here. So straight off we can see that the number of vertices is equal to 3. So V is equal to 3. Okay. In the next case, what we have to do is calculate the number of edges. So again, what I'll do here is just go around the side. 1, 2, 3. That's the external ones. And then 1, 2, whoops, and 3. So we have 3 plus 3, which is equal to 6. Okay. And then the number of regions. So we have the external region, 1. and then 2, 3, 4, and 5. So the number of regions is equal to 5. So let's just piece that all together. So we have 3, 5, and 6. So that is equal to 3 plus 5 minus 6 is equal to 2. So that again verifies Euler's theorem. So we will do one more. I'm just going to pause it again. Okay, so this is the last one here. So what we have here is we have 7 vertices. Okay, don't forget that internal one. So V is equal to 7. Now, the number of edges. So let's go around the side first. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. So that is equal to 12. Okay. And then R is the number of regions. So we have the external region, the out region, 2, 3, 4, 5, 6, and 7. Okay. So V is 7, and minus E so V is the number of regions, V is the number of vertices, R is the number of regions, and E is the number of edges. So we go 7 plus 7 minus 12. That gives us 14 minus 12, which is 2. So that verifies the Euler's theorem in that case, 4 cases. Okay, that's great. We'll leave it there.